This video is going to cover baby step 2 of 5 on our way to building up the skills for dimensional analysis. So just a simple review of algebra. We can simplify things by factoring them. This is a really simple example right here where we have 2x over 2x. Well, the 2 is separate from the x. The 2 is being multiplied by the x on top, and it's being multiplied by the x in the denominator. The 2's are the same thing as each other, and so they divide each other out and become 1. And then the x's are also the same as each other, so they divide each other out and become 1. Now we have 1 times 1 divided by 1 times 1, which is 1, over 1, which is 1. Everything cancels to 1. We say cancels. Then we could factor this one out because it's a little bit more complicated. We have 2 times x times another x. That's what the squared means, is we're multiplying x by itself. Then we have 4, which is 2 times 2, and then we have that multiplied by a single x. So one of these 2's can divide out one of these 2's. One of these x's can divide out one of these x's. So what we'd be left with that didn't divide out and become 1 would be an x in the numerator and a 2 in the denominator. So this would be the simplest we could get that expression. We can extend this to science, where instead of using variables, we can use units. The 2 represents a certain number of milliliters, and this 2 represents a certain number of milliliters. So the 2's can divide out to 1, and the milliliters can divide out as well. So we end up with just 1. We could do the same thing. Instead of x, we could have centimeters, where 2 is centimeters times centimeters, and then the 4 is 2 times 2, and there's 1 centimeters down here. So the 2's divide out to 1, there's still 1 left down here, and 2 of the centimeters divide out so that there's 1 left. So let's see if I can turn on a highlighter tool and highlight what's left. Number-wise, we have a 1 in the numerator and a 1 times 2, which would just be 2 in the denominator. And unit-wise, all we have left are centimeters. So if I rewrote this to the simplified form, it would be 1 centimeter over 2. Sometimes we have two fractions being multiplied together, and we can multiply and then simplify. So we could look at them in the brackets and know that these are being multiplied by each other. So I could either multiply them out over here and say 2 times x times 9 times y, and then 3 times 2 times x. I could multiply it out like that way, so it's one big numerator and one big denominator, and look at what divides out. Or maybe I could just see that there's a 2x being multiplied by a fraction that has a 2x in it, and know that those are going to be one numerator and one denominator, and divide them out. I'll do it in both places, and I'm going to change ink color. So I can divide out in my big one a 2 and a 2, and I can divide out an x and an x. And 3, well, 9 is actually 3 times 3. So I can divide out one of the 3's. So what I would be left with is 3y. If I look at it in its original form, I see 2x and 2x, one in the numerator, one in the denominator. So those could divide out, and then I see 9 and 3, so this could be 1 and 3, and we end up with 3y, just like we did if we multiplied it out and made it one big numerator and one big denominator. So we're going to extend this to science also. I could either multiply it out and make one big numerator and denominator, or I can look at it within the parentheses and know that these are going to become one big fraction where these are being multiplied and these are being multiplied and being divided the top by the bottom. So I see milliliters here with milliliters here, and I know that those can divide out. So I'll just scratch them out so we don't even see them anymore. I don't see anything that can divide the 2, but I see a 3 and a 9, and I know that 9 is 3 times 3. So one of these would divide out one of these. So what I don't have anymore, or I don't have the 9 anymore, I have a 3 and I have a grams. That's all I have left after I've simplified this expression. Let's try one that's a little bit more complicated, where I've got 3 sets of parentheses being multiplied together. These will make one big numerator and one big denominator. And if I look across the top and look for things that match across the bottom, I see MOL and MOL, which is abbreviation for a chemistry term, which is a mole. Well, I see a mole here and a mole underneath that could divide out and become 1. I also see some grams here and some grams here that could divide out and become 1. And then I noticed that 39 is a multiple of 3. So I could divide this and I could say 3 divided by 3 is 1, 39 divided by 3 is 13. And then I have 2 times 13 times 1, that's 26, and the only units I have left are milliliters. The other thing I could do is I could pull up my calculator if I didn't want to simplify all of that, and I could turn on my calculator. There we go. And I could do 2 times 39 divided by 3. And I would get 26. So you have a few practice problems here to do in part of your Edmodo homework. Here's question number 1. You're going to use the skills we just used of looking for common things top and bottom and simplifying. Get it as simple as you can, and then pick that answer for question number 1. You may want to pause the video and look at it. Here's question number 2. Looks very similar to one of the other ones we did as an example in this video, where we're going to look for things that are factors on the top and the bottom that we can simplify. So you may want to pause it here. And then here's the last one. This one's a refresher of baby step 1, where I don't want you to factor this in your head. I really want to make sure that you know how to use your calculator correctly. Speak calculator. How do you tell it 2 different numbers are in the denominator? Practice doing that. Make that your answer to number 3. And you may want to pause it since this video is about to end.